Hello guys, welcome back to my channel, Fun with Physics. In today's lesson, we are going to consider heat transfer. Now, which direction is the heat flowing in the examples below? Of course, in this case, the heat flows from the cuff to the hand. In this case, from the pressing iron to the clothes. And in this case, from the dryer to the snowman. How is temperature different from heat? In our previous video, we saw how temperature is different from heat. While heat is a form of energy that is given into a body, temperature is just a measure of how hot or cold the body is. Heat is a type of energy called thermal energy, like I mentioned before, and can be transferred by three main processes: conduction, convection, and radiation. Now, it is worth to note that heat can only transfer from a region of higher temperature to a region of colder temperature. Okay, so if I have these liquids here at different temperature and then I bring them together or mix them together, heat transfers from this one, the hot one, to the cold one until both get to a uniform or equilibrium temperature. Now, if you touch a wooden door and a metal door handle, which feel colder? The metal handle, of course. Now, the explanation here is that both the wooden and the metal handle are at the same temperature. But the metal handle is a better conductor, so conduct most of the heat from your hand away, so it feels colder. Now, there are different materials that respond differently to heat. Okay, some materials respond quickly to heat, that is, they allow heat to pass through them easily, while others don't or does not allow heat to pass through them easily. The ones that allow heat to pass through them easily are called conductors, like what we have here. All metals belong to this category. And those that don't allow heat to pass through them are insulators. So we have glass here, plastic, ceramics, paper, rubber, foam, fabric, wood, and so on. Now, which item do you think is the best insulator? The best insulator is, of course, air. And any material that can trap air will make an excellent insulator. We have some materials here that can hold air, like the styrofoam here, the cork here, the cotton here, or a feather here. These materials can trap a lot of air in them. They are squashy, of course, and they make excellent insulator of heat. One method of transferring heat, like I mentioned earlier, is conduction. And conduction requires contact. Okay, so the material that wants to receive the heat must be in contact with what is giving the heat. Okay, so two materials, the cold one must be in contact with the hot one, or the heat itself. So this kind of method of transfer is what we call heat. Okay, now in transfer of thermal energy by conduction, the particles closest to the heat source starts vibrating and then pass the vibration along to the ones that are adjacent to them. The process continues until the heat gets to the end of the material. Okay, during conduction, the particles of matter gain heat energy and begin to vibrate and hit each other, which I just explained here. Now, conduction is solid versus liquid. Now, which of this state of matter do you think will conduct heat more than the others? Of course, solid. Solid consists of particles that are tightly packed so they can pass their vibration along easily, okay, compared to liquid or gas. So here in this case, gases are the worst. They are poor conductors because their particles are far from each other. So when one vibrates, it is difficult to pass the vibration to the adjacent particle. Okay. Now, conduction in metal versus non-metal like wood. Which do you think will conduct better? A metal like copper and a non-metal like wood? Of course, copper. Copper is a better conductor because it doesn't just have vibrating molecules, but it also have free mobile electrons like this. Okay, so the free mobile electrons, when they are heated, they receive sufficient energy to move about. Sometimes they bump on particles and cause them to vibrate more. Okay, so why you have only uh, particles that are vibrating in wood, we have both particles that are vibrating and electrons that are free to move in copper. Okay, another reason is that the particles in copper are more tightly packed compared to that of wood. Okay, are liquids good or poor conductors compared to air? Of course, they are good conductors when you compare them to air, but are poor conductors when you compare them to metal like solid, okay, to solids. Now, we have an experiment here that shows that a liquid is a poor conductor, okay, when you compare it to a solid. Now, this is the arrangement here, a test tube with some water inside, a block of ice, and a wire gauge gas to hold the block. Okay, when one end is heated like what we have here, the temperature of this point here, we get to 100 degree to a boiling point. We will notice that the ice, in spite of the boiling liquid here, will remain, will still be ice, okay, for a long time. It will suddenly melt, of course, but it's going to take some time to do that. Okay, this shows that liquid are poor conductors. Okay, and we have learned earlier here that their particles are spaced apart, so the vibration don't get to be passed easily like solid. All right, now don't forget that a substance must be in contact before conduction can take place. Okay, if I want to conduct heat from this pan to my hand, I must touch the material. Okay, if this pan wants to conduct heat from a burning stove, it must be in contact with the burning stove. Is that clear? Another method of heat transfer is convection. This method of heat transfer requires the movement of fluid. Okay, have you ever wondered why air conditioners are placed close to the ceiling, like what we have in this case? Now, the reason is because air conditioners give out cold air, which tends to fall down. Okay, this cold air, on the other hand, pushes the warm air around us, around the room, upward back to the ceiling. Okay, now the reason why the warm air moves back to the ceiling is because they are lighter, or let's say they're less dense than the cold air. Now we can demonstrate this using this little setup here, just a balloon that you can blow in some amount of air inside. Okay, if you put the balloon inside the fridge or a freezer, you will notice that it will shrink after some time. But when you bring it out and put it close to a heat source, or maybe in the sunlight, okay, to heat it up, you will notice that the volume of the balloon is going to increase. like what we have here. Okay, this is because the particles are expanded inside. Okay, not just increase, but it will also be less dense. Okay, now the method of heat transfer that require molecules to move in this manner, warm air move up, cold air move down, is what we call convection. Okay, now convection occur in fluids. Okay, and we know the fluid is a general name for both liquid and gases. That means convection is possible in liquid. Now, one way to demonstrate this is by the use of this setup here. Okay, fill up a liquid, fill up a beaker with a liquid to any given volume. Now, you insert a tiny piece of potassium permanganate, and then you heat up the liquid from this end, from this side where we have the potassium permanganate. You will notice this color movement taking place. That's the color of the crystal that dissolved in the liquid will tend to rise, and then at a point the color will fall back. The process will continue on and on like that. This goes a long way to show that the heated liquid here tend to expand, become less dense, and rise up, while the cold liquid here, of course, is more dense. It will what? Fall back. Okay, and the process continue. Less dense rises, more dense fall back. Okay, and the process continue in the liquid. We can ascertain that this is exactly what's happening using this apparatus here. These two items here, bag, contain just air. When you hit one end, one of the bag, you will notice a rise on that side and then a drop or a fall on this other side. The reason is because of the variation in their density. The less dense one or the lighter one goes up, and the more dense or heavier one fall back. Okay? Convection can be applied or is applied in so many instances. Okay, and there are some that happen naturally. One of the convection that happen naturally is called the thermals. Now we can see a clear demonstration of what happens in the thermals. Heated air from the land rises and cold air from the sea or from a colder region flow in to take its place. Now the heated air that rose earlier is also cooled up there in the sky and fall back. The process will keep going on and on. Hang gliders, you take advantage of this phenomenon to glide in the sky. Also, birds like eagles take advantage of this also to glide in the sky. Other form of natural convection is the land and the sea breeze. The sea breeze is a breeze that blows from the sea towards the land during the day. Now, this is because by daytime the land is warmer, tend to be warmer than the sea, or is always warmer than the sea. So warm air from the land rises up, then cold air from the sea flow in to take the place, to replace it. Okay, so this kind of breeze here is called the sea breeze because it's coming from the sea. But during the night time, the opposite of this, of the sea breeze, occur. Okay, and we call it the land breeze because the wind flows from the land towards the sea. Okay, at night the sea is always warmer than the land because the land cools very quickly compared to the sea at night. Okay, so we can guess where warm air will rise from. So warm air rises from the sea, of course, and then is replaced by cold air from the land. This phenomenon, continuous process here, is called the sea breeze. okay, and they are natural convection. We have the radiation method of heat transfer. In this method of heat transfer, there is no contact, or matter is not important, it's not necessary. Okay? Contact is not necessary. Solid, liquid, or gas is not important here, because the heat transfer from the source, okay, to the object through what is called infrared wave or radiation. Okay, this is how the heat from the sun gets to us at the earth. Okay, so the heat here can transfer in vacuum. It doesn't need any medium to transfer. Okay, so the kind of heat transfer by infrared wave is what we call radiation. Now, these are cases of radiation. You don't need any contact here like what we have here. A hand close to the fire, but you feel the warmth of the fire or the sun, the heat from the sunlight. Okay. Now, different substances can emit infrared at different amounts. Okay. So basically, all substances emit infrared, give out radiation. Okay. But we can determine the extent of the radiation using what is called thermal imaging here. Okay, the thermal imaging will show us where we have more of the radiation or infrared wave coming out from, and where we have less of the radiation. Okay, now like in this case here, we have more of the radiation this side. The glass region here of this truck, we have less of the radiation in the sky here. Okay. Now, apart from the infrared radiation, we have other form of electromagnetic spectrums, also given out by sunlight. We have the radio wave, the microwave, infrared, visible light, ultraviolet, X-ray, and the gamma ray. Okay. Notice that the wavelengths here keep decreasing, and then the frequency keep increasing when you're moving from left to right. So also the energy when you're moving from left to right. Now this is a subject for another lesson. Now in summary, conduction, energy is transferred by direct contact. Convection, energy is transferred by the mass motion of molecules. Radiation, energy is transferred by electromagnetic radiation. How infrared is transmitted, absorbed, and reflected. Now let's take you back to our year 8 class. Recall that we said in our year 8 class that when light strikes on a white object, all of the spectrum is reflected. All of the light is reflected back to our eyes. But when light strikes on something that is black, all of the light is absorbed by the black object, so it appears to be black here. Okay, and this is why this one appears to be white, because it reflects all of the wave to our eyes, isn't it? Now this is not far from what infrared does. So we can guess when infrared ray strikes on a white object, a white cloth, all of the wave is reflected. That's all of the radiation is reflected. But when it strikes on a black object, all of it is absorbed. So which one do you think will be hotter? Or which one do you think is comfortable for you to wear? Which of these on a warm day? A white t-shirt or a black t-shirt? A white, of course, because all of the infrared radiation coming to it is reflected. But here, this girl will feel very hot on a very warm day. Okay, but infrared is transmitted, like I mentioned earlier, through space without requiring any material medium. The greenhouse effect. Now you must have learned about this effect in your biology class, isn't it? And we know that it has a positive side and a negative side. Okay, the positive side is that it gets warm our earth, our planet, okay, and make it habitable for us. And the negative side is that too much of warming can cause what is called global warming, okay, and lead to other problems like flooding and so on. Now, this is how it occurs. Heat from infrared from the sun hits the earth, and also the earth also releases certain amount of infrared. Okay. Now, most of it is reflected back to the atmosphere, to space. While some of it is absorbed by greenhouse gases like carbon dioxide, sulfur dioxide, and so on. Okay, these gases absorb and scatter or reflect or give off the infrared in different direction, making our globe, our world, to be warm. Okay? Did you know that marathon runners need to keep warm at the end of races? And so they cover themselves with shiny blanket to reflect heat back. Now remember what we said about white and black. Okay, it also applied to shiny. Shiny surfaces do reflect heat or infrared like white surface. Okay. Now firefighters, they need to put on shiny suits to reflect heat away from them. Okay. Now considering this fact, which area of the foil will you use to cover your ice cream or your roasted chicken? You want to keep your roasted chicken warm. Which of the area do you think would be suitable to cover it? Of course, we will need to use the matte, the rough surface here, or the dull surface to cover the ice cream, because we don't want heat to be absorbed by it, right? So the shiny surface will be outside to reflect the heat away. But for our food here, we will use the shiny surface inside, okay, because we don't want the heat from our food to go off, so it will be reflected back to the food, isn't it? All right, guys, I hope you understand this lesson. Do drop your comments on the comment section. Like this video. If there's anything I need to adjust, please, guys, I would like to get feedback from you to know the areas I need to work on. Thank you.